Hey guys, welcome back to the machine learning course for beginners. So in this lecture, we are starting with Python implementation of agglomerative hierarchical clustering. So we have seen the explanation of this algorithm in the previous lecture. So let's implement it in Python. So the Python implementation of agglomerative hierarchical clustering. It's a very interesting program. We will see the practical implementation of the agglomerative hierarchical clustering algorithm using Python. To implement this, we will use the same dataset problem that we have used for the k-means clustering, okay? So that we can compare both concepts easily. The dataset is containing the information of customers that have visited a mall for shopping. So the mall owner wants to find some patterns or some particular behavior of the customers using the dataset information. So the steps for implementing this agglomerative hierarchical clustering are: the first step is data pre-processing. The second step is finding the optimal number of clusters using the dendrogram. The third one is training the hierarchical clustering model. The fourth one is visualizing the clusters. Okay, so we will do all these things in this program. So the first one is data pre-processing steps. So in this step, we will import the libraries and data sets for our model. So the libraries we need are NumPy, Matplotlib, and Pandas. Okay, so let's import them first using the import statement. Okay, it's loading. So it takes them some time to load. Okay, so let's import NumPy, Pandas, and Matplotlib. Okay, so after this step, so these lines of code are used to import the libraries to perform specific tasks. So for example, NumPy for the mathematical operations, Matplotlib for drawing the graphs, and Pandas for importing the data set. So we will create the data set in this example for this mall customers data using the dictionary. So data set equals the columns. We have few columns here. The columns are index, then customer ID, then gender, then age, then annual income. So these are our input, and the output is the spending score. No, these are not the output, sorry. These are all the inputs. So because the data is unlabeled, right? So we don't have the output here. So index customer ID, gender, okay. So this is the data set we are creating. Now we need to input some values. So the index will be from 0 to 15. So we have totally 16 values. The data set can grow on, but for the sample purpose, I have just kept few rows. Okay. So there are totally 15 rows. Then we have the gender. So I'll just write M or F. So we have gender, age, annual income, and spending score. Okay. So after this, we enter the age, annual income, and spending score. Okay, so we have these genders, then now we will do the age. So these are the ages. Next is the annual income. in $1,000. Okay, so these are the annual income. The next and the last is the spending score. So it is 1 to 100. So once this is done, the next step, we will convert this data set into a data frame using the data frame function. Okay. And in this data set, all columns are not important. So we will extract only the relevant columns for the clustering. So now we convert this data set to the data frame using the data frame function. So df equals pd.dataFrame data set comma columns equal to index, customer ID, gender, age, annual income, and spending score. Okay. Okay, so the data frame is ready. Now the next step is to extract the matrix of features. So here we will extract only the matrix of features as we don't have any further information about the dependent variable. So how to do that? So we want to extract only the column numbers 3 and 4. Okay, 0, 1, 2, 3, 4. So we need to close the bracket here. So close the bracket after the df. Okay, okay, it should be matplotlib. So we have our output here, the data frame. So now we extract the matrix of features. So I will write x equals df comma df dot I location. I want all the rows, so I will write colon. Then I want only column number 3 and 4, that is age and annual income. So column number 0 is index, column number 1 is customer ID, column number 2 is gender, column number 3 is age, column number 4 is annual income. So I'm extracting only column number 3 and 4, the values of these columns. So I'll write dot values. Values is an attribute. So print x. Okay. Yeah, we have done a mistake. So we have got these matrix of features, the column number 3 and 4. So column number 3 is age and column number 4 is annual income in $1,000. So this is the X. We are taking this as the input. So we have extracted only 3 and 4 columns as we will use a 2D plot to see the clusters. So we are considering the annual income and spending score as the matrix of features. So here actually the column number 3 and 4 are not age and annual income. The column number 3 and 4 are annual income and spending score, because I have just created one extra column, that is index, which is naturally created when I create a data frame. So you can ignore this, the first column, the column number 0, that is index. So the column number 0 is customer ID, column number 2 is gender, no, column number 0 is customer ID, column number 1 is gender, column number 2 is age, column number 3 is annual income, column number 4 is spending score. Okay, so you can do that modification in your program when you write. So don't consider the index. You can completely remove the first line of the data set, that is index. The index will be automatically created. So in your data set, the column number 0 should be customer ID, column number 1 should be gender, column number 2 should be age, column number 3 should be annual income, and column number 4 should be spending score. Okay. So let me show you first how the clustering will take place when we select age and annual income as matrix features. Then in the next lecture, I will show you the matrix features being the annual income and spending score. So we printed the X value. Then we find the optimal number of clusters using the dendrogram. So now we will find the optimal number of clusters using the dendrogram for our model. For this, we are going to use the SciPy library, as it provides a function that will directly return the dendrogram for our code. So the line imports scipy.cluster.hierarchy as SHC. So that will directly give a dendrogram for us. Now create an object dendro equals shc.dendrogram shc comma linkage of x method equals word. So this means we have imported the hierarchy module of the SciPy library, correct? This module provides us a method shc.dendrogram, which takes the linkage as a parameter. Okay, it takes the linkage as the parameter. The linkage function is used to define the distance between two clusters. So here we have passed the X, that is the matrix of features, that is age and annual income, and the method word, the popular method of linkage in hierarchical clustering. So we are using this word method of linkage for hierarchical clustering. So then we can give X label, Y label, and the title. So the linkage, the word linkage criterion determines which distance to use between sets of observations. The algorithm will merge the pairs of cluster that minimize this criterion. The word minimizes the variance of the clusters being merged. Average uses the average of the distances of each observation of the two sets. Okay, so this is the meaning of the word function. Then we can write the title is the dendrogram plot, the Y label is Euclidean distance, the X label is customers, and then we can use the show function. So by doing this, the code will be executed and we get a dendrogram. So we got this dendrogram. The MTP is not defined, so it should be PLT or MTP. So what is the error? Okay. Yes, we have got this dendrogram. So how the dendrogram has joined the clusters based on the distance calculated. So you can see it in the dendrogram. So 4 and 9, and then 6 and 11, then that cluster with 14, and that cluster with 4 and 9. Like this 3 and 5, that with 7, that with 13, and that with 0, 2, and 1. That so like this, the dendrogram has been calculated. So okay. So using this dendrogram, we will now determine the optimal number of clusters for our model. For this, we will find the maximum vertical distance that does not cut any horizontal bar. So the next step, the optimal number of clusters will be 5. So it depends on what example you are doing. So in this, we got that dendrogram, what I showed you. The next step is to train the hierarchical clustering model. So as we know, the required optimal number of clusters, we can now train our model. The code is given below. So for that, we need to import from sklearn.cluster, import agglomerative clustering. So with this, we will stop at this point. In the next lecture, I will complete this example and show you the output. Okay, so just practice this using the age and annual income as the feature matrix. So we will complete it in the next lecture. All right, thank you.